I thought this was an algebra exam, not a graphs exam. Well, we can use both. That's totally fine. So we have a quadratic graph, right? 12x squared minus x minus 6. And we're asked, where does it cut the x-axis? So graphically, just a refresher, this is a positive parabola, right? Because the coefficient of x squared is a positive number. So it'll look something like this, right? It's positive, it's happy. And the y-intercept is -6. So that's this point here. And then we're looking for these points. One could be negative and one positive, or they both could be positive. Both could be negative. Could they? No, they couldn't, because the y-intercept is -6. But we'll come to that. So that's what it looks like graphically. So if you wanted to solve this really quick, you can just graph it. So let's do that. However, it is an algebra exam, so you do need to do a little bit more than that. Sorry. So menu, graph, y, and we go y equals our function. So 12x, which is under alpha, squared, minus x minus 6. Execute, and we can hit draw. So that's what it looks like. It's a bit cut off, right? You see, we don't see the bottom. We can use the arrow to go down. There it is. That should be at -6. But we're interested in where it cuts the x-axis. Another word for that is, where are the x-intercepts? Right? So on our calculator, we hit F6. Wait, we hit F5, gsolve. We hit root, so that's F1. And root is the x-intercept. So there's an x-intercept at -0.667. And x equals 0.75. All right, and technically we have answered the question, but I'll show you how to do it algebraically. But before we even did it algebraically, it's good to have an idea of what the graph would look like, so we knew we were expecting one negative and one positive solution. And by graphing it, we can confirm our solution as well. But let's do it algebraically. So the x-intercepts are when y is equal to 0, right? So that restricts us to the x-axis. If y could be 4, it would be these points here, which is not what we're looking for. We're looking for the x-intercepts. So we set y equal to 0. So we have 12x squared minus x minus 6 equals 0. And now we're just solving this quadratic equation for x, and those solutions will be the x-intercepts. So for this one, how's about let's use the quadratic formula for this. So quadratic formula, just a reminder, this isn't the only way to do it, but let's practice using it. Right, that'll be in your formula book, where a is 12, b is -1. Oh, I missed an a. And c is -6 in this example. Right, so the coefficient of x squared of x and then the constant. So all we do is substitute in those values. So negative b is -1, plus or minus, that's a bit annoying, that highlighter, go away. Oh, so negative b, where b is -1, plus or minus -1 squared, so that's b, minus 4 times a, which is 12, times c, which is negative 6, all divided by 2 times 12. Now let's simplify this a bit. Negative, negative 1, positive 1, plus or minus 1 squared is 1. Then we have, what is that? Save some time. Oh, menu, run maths. Negative 4 times 12 times negative 6. Positive 288. 288. Let's just add that to 1. So 289. That's square root over 24. So 1 plus shift x squared, so square root of 289. That is 18 divided by 24 is 0.75. So that's for the positive solution. Now let's do the negative solution. So that will be 1 minus the square root of 289 divided by 24, which is negative 2/3, or negative 0.667. And this one would actually be 3/4, or 0.75. Fraction or decimal, doesn't matter. And look at that, we have the same x values, or the x-intercepts. So 2 methods you could solve this question. Do it algebraically first, but do also check graphically.